Introduction to the Messerschmitt Me-262A-1. The Messerschmitt Me-262A-1, known as the Me-262, marks a remarkable milestone in World War II aviation. Imagine a fighter jet ahead of its time. What made this German marvel stand out? How did its jet-powered engines redefine air combat? Join us as we uncover the Me-262's journey from its groundbreaking design and construction to its unmatched speed and firepower. How did pilots adapt to its advanced technology? What were the challenges it faced in combat? Explore with us as we unravel the enduring impact of this pioneering aircraft on military history, design, and construction. The Me-262 stood out with its sleek design, a low-wing, twin-engine plane that was ahead of its time. Its fuselage, about 34 feet 9 inches long, had a distinctive triangular shape that helped it glide through the air smoothly. This shape wasn't just for looks, it was carefully chosen to reduce air resistance and make it easier to build and maintain during the war. During World War II, there were shortages of lightweight metals needed for planes. To get around this, the Me-262 used a mix of steel and aluminum alloys in its construction. It even got creative, using plywood for non-essential parts like fuel tank covers and control panels. This improvisation showed how resourceful engineers had to be in wartime. How did these design choices affect the Me-262's performance in combat? What challenges did pilots face flying such an advanced aircraft? Let's explore how these innovations shaped the course of aviation history during the war and beyond. Wings and aerodynamics. The Messerschmitt Me-262's wings were meticulously engineered to enhance its aerial performance. Featuring a robust metal double-spar structure, these wings incorporated automatic slotted wind slats along the leading edge. These slats are deployed automatically to increase lift during slow flight or tight maneuvers, a critical advantage for intercepting enemy aircraft. On the trailing edge of the wings were flaps that extended during takeoff and landing. These flaps enlarged the wing's surface area, boosting lift at lower speeds and aiding pilots in managing complex maneuvers. To maintain stability, the ailerons responsible for rolling the aircraft were split into two sections. This innovation minimized aerodynamic disturbances caused by the engine nacelles, improving overall flight control and maneuverability for Me-262 pilots. These advanced wing technologies significantly bolstered the Me-262's combat performance. The automatic slotted wind slats and extended flaps allowed for swift adjustments in flight, crucial for engaging enemy fighters and bombers effectively. Pilots benefited from improved maneuverability and control, which proved vital in aerial engagements. However, using such cutting-edge technology presented challenges. Pilots had to master new flight techniques to fully exploit the Me-262's capabilities. Managing the aircraft's speed, handling, and intricate controls during combat demanded skill and adaptation. These innovative wing designs underscored the Me-262's impact on aviation history. They set a precedent for future aircraft developments, influencing how wings and control surfaces were designed for enhanced performance and maneuverability. The Me-262's legacy continues to resonate in modern aviation, reflecting its pioneering role in shaping the evolution of fighter aircraft and aerial warfare tactics, engines, and performance. At the core of the Messerschmitt Me-262's remarkable performance were its two Jumo 0004B1 turbojet engines. These engines, each capable of generating approximately 8.83 kilonewtons, about 1,984 pounds of thrust, represented a significant leap forward in aviation technology during World War II. What set them apart was their status as the world's first successful axial-flow turbojet engines, pioneering a design that would serve as the foundation for all subsequent jet engines. Operating the Jumo 004 was a feat of innovation for its time. Air entered the engine through its front intake and was compressed by an 8-stage compressor, increasing its pressure and temperature. This compressed air then entered one of 6 combustion chambers where fuel was injected and ignited, creating intensely hot gases. These gases were expelled at high velocity through a rear nozzle, propelling the Me-262 forward with considerable speed and power. A notable feature of the Jumo 004 was its movable inner cone, affectionately known as the Zwiebel German for onion bulb due to its shape. This cone allowed engineers to adjust the flow of exhaust gases, optimizing the engine's thrust output and efficiency based on different flight conditions, a pioneering concept in engine design. Despite its groundbreaking nature, the Jumo 004 faced challenges typical of early jet engines. Reliability was an issue, and maintaining peak performance required frequent and meticulous maintenance. These challenges notwithstanding, the Me-262 equipped with Jumo 0004 engines made a lasting impact on aviation history. The introduction of these powerful engines fundamentally altered air combat during World War II. The Me-262's speed and agility gave it a significant tactical advantage over Allied aircraft, demonstrating the potential of jet propulsion in military operations. Engineers learned invaluable lessons from the Jumo 004's development, refining subsequent jet engine designs to enhance reliability, efficiency, and performance. This technological leap forward not only influenced the evolution of military aviation, but also paved the way for modern jet-powered aircraft, shaping the future of aerial warfare and civilian aviation alike. How did the Jumo 004-powered Me-262 influence post-war aviation advancements? What technological innovations stem from its development that continue to impact aviation today? Exploring these questions illuminates the enduring legacy of the Me-262 and its pivotal role in the history of jet propulsion. Armament and combat role. Armed with potent weaponry, the Messerschmitt Me-262 featured 4 MKs, 108 30mm cannons as its primary armament. These cannons fired explosive shells at a rapid rate of approximately 650 rounds per minute, propelling them at 520 meters per second, about 1,507 feet per second. This firepower allowed each cannon to effectively target and destroy Allied heavy bombers like the B-17 Flying Fortress or B-24 Liberator with just a few well-placed shots, showcasing their lethal effectiveness in combat situations. In addition to its cannons, the Me-262 could also be equipped with underwing racks for launching unguided rockets, such as the R-4M weighing 4 kilograms around 8.8 pounds. These rockets were versatile, designed to attack both enemy aircraft and ground targets. While they lacked precision compared to cannons, their ability to be deployed in large numbers compensated for this limitation. This strategy illustrated German efforts to enhance the Me-262's versatility across different combat scenarios. The combination of cannons and rockets significantly influenced the Me-262's tactics in aerial engagements. Pilots could engage enemy bombers from a distance using cannons and then switch to rockets for broader, area-targeted strikes against ground positions. However, using these weapons posed challenges. The cannons required precise aiming due to their limited ammunition capacity, while rockets demanded careful timing and positioning to maximize their effectiveness against moving targets. How did these innovative armaments affect the Me-262's operational effectiveness against Allied forces? What strategic adjustments did pilots make to optimize the use of cannons and rockets in combat? Exploring these aspects provides deeper insights into how the Me-262's weaponry shaped its combat strategies and contributed to its impact on the outcome of World War II. Operational challenges and legacy. Despite its advanced technology, the Messerschmitt Me-262 faced significant challenges during World War II that severely limited its effectiveness. Production delays, logistical issues, and a shortage of trained pilots meant that only a fraction, around 300 out of approximately 1,470 Me-262s produced saw actual combat. This shortfall was a missed opportunity for Germany, which needed more of these revolutionary aircraft to make a substantial impact. In combat, the Me-262 left a lasting legacy primarily as a pioneering jet interceptor. As one of the first operational jet-powered planes used in warfare, it showcased the potential and power of jet technology in military applications. However, its introduction came too late in the war and in insufficient numbers to decisively alter the course of history. Despite these setbacks, the deployment of the Me-262 marked a pivotal moment in aviation history. It demonstrated that jet-powered aircraft were not merely experimental concepts but could be practical and formidable weapons of war. The lessons learned from its design, development, and combat use influenced subsequent generations of fighter jets worldwide, shaping the evolution of military aviation for decades to come. How did the operational challenges faced by the Me-262 impact its combat performance? What were the key technological advancements introduced by this pioneering aircraft? These questions underscore the enduring significance of the Me-262 as a symbol of innovation and a catalyst for the advancement of jet aviation in the modern era. In conclusion, the Messerschmitt Me-262A-1 Schwalbe stands as a lasting symbol of innovation and technological progress during World War II. While its influence on the war's outcome was constrained, its impact on aviation history remains profound. How did the Me-262's design and deployment pave the way for future jet aircraft? What enduring lessons did its development teach about the integration of advanced technology in military operations? Its legacy endures through the continued evolution of jet aviation, highlighting its pivotal role in shaping the modern era of aerial warfare. Don't miss out on our deep dives into iconic aircraft like the Messerschmitt Me-262. Subscribe now for more fascinating insights into aviation history. Hit that subscribe button to join us on this journey through military aviation.